Linus Torvalds is one of the most famous and influential computer scientists in the entire world. And he gave his thoughts on using artificial intelligence to code, and it is fascinating. So we're going to watch the interview with him together in this video. So before we get into the video, let me just show you a little bit about Linus. So first of all, he's the creator and lead developer of the Linux kernel. No big deal. And also the creator of Git, the versioning software that basically every single software company uses. He created Linux as a free and open source alternative and is still actively involved to this day. So if anybody is qualified to give their opinions on artificial intelligence and coding, it is him. Let's watch this video. So this guy on the left is Linus Torvalds.
I typically say artificial intelligence is autocorrect on steroids, because all a large language model does is it predicts what's the most likely next word that you're going to use, and then it extrapolates from there. So not really very intelligent, but
all right. Obviously, this guy has a very strong opinion of AI, and this has been debated over and over again. Is all AI doing predicting the next token, or does it actually have a deeper intelligence? And right now, it's probably leaning more towards just predicting the next token, which in itself is an intelligence, but fine. Soon, we will have other technologies, other techniques that go way beyond just predicting the next token. Let's keep watching.
obviously the impact that it has on our lives, on the reality we live in, is significant. Do you think we will see LLM written code that is submitted to you as a pull request?
I'm convinced it's going to happen, yes. It may well be happening already, maybe on a smaller scale where people really use it more as a help in writing code. But automation has always helped people write code. I mean, this is not anything new at all.
And by the way, this video came out at least 7 months ago, so it's a little bit older. But he already says, yeah, it's probably happening already. Fast forward 7 months, it's definitely happening. And especially with the explosion of cursor usage, the IDE that is AI native, everybody seemingly is building code, even if you don't know how to code. But then he continues and says, automation has been helping. And yeah, automation and programming go hand in hand. And this is just the next level of automation.
We don't write machine code anymore. We don't even write assembler. And now we're moving on from C to Rust. So I don't see this as something as revolutionary as all the news talk is every day about AI.
So what he's explaining is how abstraction works. In the very beginning, we were writing ones and zeros. Then we had machine code, and then we continued to abstract layer after layer on top of that to make it easier for humans to write code that machines can understand. And today, we don't write machine code. We write these high-level languages, C, Rust, Ruby, Python, all of these languages that then get translated down into binary in which a computer can actually understand and run. And that's what he's explaining. This is the next level and potentially the last level of abstraction. It is natural language. No longer do you have to be precise and exact with your explanation of what you want out of the functionality of code. You just explain it in fuzzy terms, and the large language model will then translate that into a coding language that will eventually be translated all the way down to machine code and binary. Now, here's the interesting thing that I've been thinking about for a while. Eventually, large language models and AI in general will write more and more of the code that we use every day. And at a certain point, the large language model probably will write code in a language that doesn't look familiar to us at all, because they don't need to. The reason why we've had these layers of abstraction on top of machine code and binary is because humans are really bad at writing code. We can't read binary. We can't even read machine code very well. It takes us a long time to understand what's going on. But large language models don't have that problem. So eventually we might see a coding language that is completely foreign to us. Maybe it's even symbols. Who knows what it's going to look like? Because the only ones that are really going to have to understand it is the AI. And yeah, there's a whole set of implications that come from that. We're not going to touch on that in this video. Let's keep watching.
But so you say you expect this can help people write code, this can help people get started. But then if we look at the previous conversation and the challenges around code reviews and maintaining, so do you think that large language models will get to the point that they can help us review code, that they can help maintain subsystems?
I hope, because that's certainly one of the areas where which I see them really being able to shine, to find the obvious stupid bugs. Because, I mean, how many people here are actually programmers in this room?
A lot.
So, a fair number. A lot of the bugs I write, a lot of the bugs I see other people write, they're not like subtle bugs. A lot of them are just the stupid bugs that you did not think about, and you don't need any kind of higher intelligence to find them.
All right, so he is 100% true. I was just talking to a buddy of mine who works at Microsoft, and they're using AI to do code reviews. And he said for the most part, it's not super helpful. I think it'll get there, but this is his opinion. It wasn't super helpful right now. But the point is, the bugs that it does catch that are helpful are the ones where maybe it's a misspelling, or it's like an off by one error, or something like that. Very obvious bugs that could and should have been caught by a human, but for whatever reason it didn't. But it might not currently be able to catch the subtle bugs, the issues with the functionality, the issues with the business logic. But maybe, we'll see.
But having tools that warn, I mean, we have compilers that warn about the obvious, really obvious ones, but having LLMs that warn about slightly more subtle cases where it may just say, this pattern does not look like the regular pattern. Are you sure this is what you mean?
So we already have something called linters, which checks your code for syntactical errors and other obvious things that can be programmed to check against. But now what he's explaining is large language models can maybe check more sophisticated errors, which is looking at a pattern that you used in your code and saying, hey, I see you've used this other pattern a bunch of times and you're maybe trying to replicate that pattern, but it's not exactly right. That would be really awesome.
The answer may be, no, that was not at all what I meant. You found an obvious bug. Thank you very much. So I do think that LLMs are going to be a big, you call them disparagingly, like autocorrects on steroids. And I actually think that they're way more than that. And how most people work is, we all are autocorrects on steroids to some degree. And I see that as a tool that can help us be better at what we do.
Yeah, so look, he called it autocorrect on steroids, and Linus said, well, then we're all autocorrect on steroids. Humans learn from the environment. We ingest all of this data through our eyes, our ears, our different senses. We learn from it and we develop pattern recognition, which is essentially how large language models work. And when we're talking, when we're responding, maybe we are just trying to predict the next token in our own sentence. We could just be very sophisticated large language models.
But I've always been optimistic. The whole
Hopeful.
Hopeful was the word you had.
Yes. Helpful, hopeful, and humble.
Hopeful and humble, that's my middle name. But on the other hand, I mean, I have been so optimistic that 32 years ago, I was stupid enough to think that you can write a better kernel than anybody else. So you have to kind of be a bit too optimistic at times to make a difference. So my approach to LLMs really has been that, hey, this is wonderful.
I love seeing the optimism. I don't necessarily share it.
Yeah, no, a lot of people disagree with me.
One of the things that I worry about in all this is we see the hallucinations. We see, and that's a technical term for LLMs, they do hallucinate and they do make up stuff. And so the more they are being put into the position where they will automatically do things without an actual human being there to catch them, the more this becomes scary. Not scary as in they will rule the world, and not in the sci-fi sense, but in the so many bugs that will happen and that will affect our lives or our code.
So he's talking about hallucinations, and if you watch this channel, you know what that is. It's basically when large language models get something wrong, but say it with such confidence that it looks like they think it's right. Now, here's the thing. Humans make mistakes. Large language models being absolutely perfect is probably never going to happen. We're probably going to continuously reduce the number of hallucinations that large language models generate through techniques like QStar and Strawberry, long-term thinking, multi-agent systems, other ways to verify and validate the outputs, but it probably won't ever be perfect. But that's why you write tests and you do other things to protect the code against bugs that humans would write. We basically have to treat the large language models the same way.
Well, I see the bugs that happen without them every day, so that may be why I'm not so worried. I think we're doing those just fine on our own.
All right, so he has the same sentiment as me. Basically, humans make mistakes, large language models make mistakes. We have to have systems in place that hopefully prevent those mistakes from making it into production and also minimizing the resulting impact of those mistakes, especially for mission critical code. Now, here's another interview with the same guy, Linus Torvalds. And again, he talks about AI with coding. And this is a more recent interview, so let's watch it together.
Let's go for something that's fun and entirely non-controversial. So let's talk a little bit about AI and large language models. And so obviously, this is the current hype kit on the block. And if you want to double your salary, add AI to your title. And it's hilarious to watch the self-description of companies, and every company on earth has an AI angle to their story as of this year.
Yeah, it's very true. Every single company is now powered by AI. Pottery Barn, powered by AI. And it basically 10x's your valuation overnight.
But what I find so interesting is this idea that Gen AI is going to be the end of, insert whatever, end of programmers, the end of authors, the end of movie creators, the end of so many jobs. So you are going to be replaced by an AI model.
Finally. Yeah. No, I don't know. I hate the hype. At the same time, I think AI is very interesting. When I went to university, we were still talking about rule-based expert systems and Bayesian logic and all of this kind of thing. And it was called AI, but it was not in any way intelligent. And I do think that the last few years have been interesting.
Neither is today's.
Yeah. But I don't want to be part of the hype. Yeah. And I will say that the AI revolution has had, even on the kernel level, a few positives. For example, a company like NVIDIA, who is not exactly famous for being great at interacting with the kernel community, has actually been much more active and been involved in the Linux memory management code, because suddenly they start caring about Linux when they are selling a lot of AR hardware. Mm-hmm. I mean, it used to be crypto, and it's still obviously GPUs, and it's being used in big servers and running Linux. So it has actually had a positive impact, but my personal opinion is let's wait 10 years and see where it actually goes before we make all these crazy announcements of your job will be gone in 5 years.
I kind of disagree, especially for programmers. I really think 10 years from now, there's going to be very few application developers. What is the point of building an application when you can get the exact information that you want from a large language model directly? You're simply going to say what you want and it will give it to you. Let's use a really basic example, a to-do app. Rather than having a to-do app, you simply tell the large language model, remind me of this thing at this time. And it will know to store it. It will know when to remind you. And there's no need for the actual to-do application because the large language model is the application. And that can apply to any amount of sophistication in the application that you want. You simply tell the large language model what you want and it will give it to you. That's why I truly believe maybe 10 years is a bit aggressive, but the application layer is going away. There's just no reason for it. It's going to be natural language to AI, direct to compute.
I think we already see lasting and almost irreversible change happening through many of these AI tools, not on the hype Gen AI front, but just in the tools that make our lives better and easier. I keep calling it autocorrect on steroids, and people are mad at me. But if you use a Gen AI and hopefully an SLM tool to help you with basically code completion in your editor, Isn't that a huge opportunity?
So I'm actually, I'm one of those people who are very optimistic about AI, and I'm looking forward to the tools to actually find bugs. We have a lot of tooling around the kernel and around any software project, obviously, and we use them religiously, but making the tools smarter is not a bad thing. And I, to some degree, compare it to writing things in assembly, which literally I started doing with the initial kernel was, I think, about 50% assembly language, and using a compiler. And using smarter tools is just the next inevitable step. So that's going to happen, but I don't think it's necessarily the gloom and doom that some people say it is, and I definitely don't think it's the promised world that the people who are having their hand out for cash say it is. So you need to be a bit cynical about this whole hype cycle in the tech industry. I hope you all realize that. Before AI, it was crypto. Before crypto, it was whatever. It's
cloud native.
Cloud native.
There's a loud voice in the front. That's not hype. Okay.
I mean, the hype. There's always like a grain of reality behind it, but you need to be careful.
Yeah, these things that they're mentioning that are hype, these are real trillion-dollar companies and products. So I don't know how much hype it really is. Cloud native, I mean, the cloud infrastructure powers everything on the internet nowadays. So it's certainly not hype.
I look at these tools and I look at, you said assembler, and then we talk about compilers, then we talk about things like Sparse, a compiler that tries to find certain kinds of bugs. We talk about Julia to do code refactoring. We have had, for the last 30 plus years, a sequence of tools that helped make development better and more robust. And in that lineage of things, I hope there is really cool stuff coming down.
Yeah, I mean, we have tools that do kernel rewriting with very complicated scripts and pattern recognition and things like that. And that is actually literally why I think AI can be a huge help, because some of these tools are very hard to use because you have to specify things at a low enough level that the natural reaction would be to, hey, can we make this a bit easier and automate more of it?
So what he's describing is deterministic scripts, code, that could improve other code. And that's how it's been done. A lot of essentially decision trees. If this, then that. And that can only go so far because those get incredibly complex really quickly. And so if we have this non-deterministic way through large language models to essentially apply the pattern recognition without having to specify every single rule, all of a sudden we have this enormously powerful and valuable tool that we can use to improve our code, even write our code that wasn't previously available.
One of the interesting angles that this whole large language model and the training data brings up is the role that data plays in our modern world, where we all talk about open source, about the source code, the algorithms being available, but open data really is kind of almost the more interesting question.
No, it's not. Well, I mean, it's not to me, and actually, I'd like to clarify that, I mean, the LF obviously has open data projects, and to other people it's more interesting. And that is, I think, for me, the point of open source is that different people are interested in different things. And I was always interested in the low-level nitty-gritty of how the...
All right, so let me just stop him for a second. I actually think the guy on the right is correct. He said open data is actually more interesting than open algorithms. And look, both of them are important, but the data is seemingly harder to come by. Algorithms are out there and they're being used, and every time a research paper comes out, the entire community can use it and understand it and try to implement it in the way that they best see fit. But the data seems to be behind closed walls for the most part, and all of the data that is open has already been used to train models. So they need new data. They need more data. And where do you get that from? That's why open data is very, very interesting. So that is what Linus Torvalds, one of the most famous programmers in the history of programming, has to say about AI and programming. And what do you think? I have pretty strong thoughts about this, and I've talked about it at length in previous videos, but I want to know what you think. Drop your comments below, and if you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.